Click the bell icon to get latest videos from Ekeeda.
Hello friends, so now we have a problem, a numerical problem, wherein we are going to find out the order in which the diffraction is going to take place. Not only that, but from this information we are also going to find out the grating element. And mind you, we are being provided with two different wavelengths. Here is the problem. A diffraction grating used at normal incidence gives a line 5400 angstroms in a certain order superimposed on another line 4050 angstroms of the next higher order. If the angle of diffraction is 30 degrees, how many lines per centimeter are there on the grating? In order to understand this particular problem, let us draw a simple diagram. Here is a diffraction grating, for example. Here is a normal. Here we have the screen, and here is one diffraction angle, and so let us say, let that be your value of n, and there is another one that is falling on the same, and this particular value is turning out to be n plus 1, and this is of the next higher order, that is n plus 1. We now write down the equations for this. So the equation, the grating equation, will be equal to a plus b into sine theta is equal to n into lambda 1, and this is going to be equal to a plus b, that is for the second wavelength. This is going to be sine theta is equal to n plus 1 into lambda 2. We have to be careful to choose lambda 2 as less than lambda 1. So your lambda 1 is going to be equal to 5400 angstroms, and your lambda 2 is going to turn out to be 4050 angstroms. The left hand side of these equations are the same, and hence we can equate the right hand sides of this equation to write down as n into lambda 1 is equal to n plus 1 into lambda 2. We simplify this equation further. So we simplify this equation further to write this down as n into lambda 1 is equal to n into lambda 2 plus lambda 2. We find out the difference, n into lambda 1 minus of n into lambda 2 is equal to lambda 2, and hence your n will be equal to lambda 2 divided by lambda 1 minus lambda 2. We now substitute the values for lambda 2 and for lambda 1 and obtain the value for the order n. So here are the values, and hence this turns out to be approximately, you can check it out, this turns out to be n is equal to 3. So our first problem is solved, wherein we have found out the order as n is equal to 3 for the wavelength 5400 angstroms. Our next problem is to find out the value of the total number of lines per centimeter, and for that we use the grating equation for one of the wavelengths, that is either for lambda 1 or for lambda 2. Let us use this equation for the wavelength lambda 1, which is 5400 angstroms. So the part B of the problem will now comprise of A plus B is equal to m into lambda divided by sine theta. I take the inverse of this, and therefore 1 upon A plus B will be equal to sine theta upon m into lambda. We know the value of sine of theta, and the value of sine of theta is sine of the angle which is equal to 30 degrees divided by the order which is in this particular case. So you can say either this order is M or N. We have taken it as our N. So this is going to be equal to 3 into 5400. We will have to multiply this by 10 raised to minus 8 in order to convert it into centimeters, and hence your 1 upon a plus b, which will give you the total number of lines per centimeter in the given grating as, so this value turns out to be 3086 lines per centimeter. Hence, the total number of lines in the given grating turns out to be 3086 lines per centimeter. Sincere thanks students for watching this particular video. Stay tuned to Ekeeda and do subscribe to Ekeeda. Thanks a lot.